Hello AP Calculus students. This is the collapsing sum convergence test. So if you have a fraction similar to this one, we're going to use the concept of partial fractions to sort of decompose the series, and then that will be a way for us to collapse, or sometimes it's called telescoping sum, and collapse down the terms to get the sum of the series if it's convergent. So the first thing we need to do here is break apart this fraction. And again, there is a video on partial fraction decomposition, so this is what we're going to do here. Multiply by the product of the denominators, and then we can let n be -1 to start. That will cancel our a value. We get 1 equals b times -1, so b is -1. And then we can let n equals 0, that will cancel our b, and so a is 1. All right, so here is our original series, and we're going to start at n is 1, go to infinity, and we're going to rewrite this now as this new fraction decomposition that we have. So we're going to have 1 over n, and I'm just going to make this -1, so I'll bring that minus down just so that it's a little easier for us to simplify. 1 over n plus 1. Okay, so I'm going to list out some terms now using our new series formula. So if n is 1, we get 1 minus 1 over 2. And I'm not going to combine those terms because you'll be able to see the collapse if we do it this way. So that's our first term, n is 1. If n is 2, I get 1/2 minus 1/3. If n is 3, we get 1/3 minus 1/4. We'll do one more here. So we have n is 4, so we get 1/4 minus 1/5. All right, so we have the first 4 terms listed out. I'm going to continue the pattern kind of indefinitely here. We're going to go out to the nth term. So obviously the nth term is just this generator, right? And this is going to continue, but what we'll do is we'll just cap it there. We'll make this a nth partial sum. And so what you can see then is that there is this collapse that forms. So for instance, the -1/2 collapses with the +1/2, -1/3 with the +1/3, -1/4 with the +1/4. The -1/5 would cancel with, you know, the next term that we didn't end up listing there, in addition to the 1 over n. So the 1 over n would collapse with the previous term there. So we are left with just kind of 2 items here. So again, this is the nth partial sum, which we have a 1 in the front. We also have this minus 1 over n because we capped it, so to speak, at that nth term. And so that one would not end up canceling based on what we have here. So we have a very large series, but it's not infinite in nature. Now if we take the limit as n goes to infinity of this nth partial sum, we get 1. So the nth partial sum has a value of 1, and there's a theorem in the study of series that says that if the nth partial sum has a limiting value, in this case 1, then the series also has that particular value. And so therefore, this series that we're looking at here does converge to 1, and that's the collapsing sum technique.